Today we're continuing on with our applications of derivatives, Unit 4B. Today and all of next week we're going to learn some foundations. We're going to learn it piece by piece, and then ultimately where we're going with this is curve sketching. So today and next week we're going to learn the first derivative, second derivative test, learn little bits and pieces about min, max, inflection points, and then the week after that we're going to have a whole week on curve sketching. Now it's similar to what we did last year or last term, remember, with our rational functions. So we're back to graphing polynomial and rational functions. We're going to apply our knowledge of limits and derivatives to get the asymptotes, horizontal, vertical asymptotes, get the min, max. Remember grade 12 I said as long as we had our intercepts and the shape and endpoint, we didn't care about the min, max. Now we do. So we're going to use our derivative knowledge to get the min and max points, the inflection points, concavity, things like that. So the next 2 and a bit weeks are all about curve sketching, but like I said, we're going to break it up piece by piece. So there's 2 mini lessons today, and they're not that bad. So the first one is something called critical numbers. Basically a critical number, sometimes it's called critical points. I'll call it CN to shorten it, critical numbers. The values for where the first derivative is 0 or undefined. So we've done work like this. It's basically one of our steps when we made a sign diagram back in grade 11 pre-cal. So today's lesson should be pretty easy. So how do we determine, or how do we find the critical number for a function? So step number 1, find the first derivative. That will be really easy for you. We've been doing derivatives for over a month, so that's easy. Find the first derivative. Then express it as a series of linear factors. So factor and simplify it first. So step 1, get the first derivative, simplify and factor it as much as you can. Then from the factored point, when it's already factored, you should be able to determine which values make the denominator and or denominator 0. And like I said, those are our first 2 steps when we made a sign diagram. That's where we are eventually heading to next week. So we're laying the groundwork to get that. So step 1, get the first derivative, factor, simplify, figure out what values would make the denominator or numerator 0 from the first derivative, and that's where you get your critical numbers. Just to make a note, for a critical number to exist, it has to be defined in the original function. So once you have your values, always go back and look, does that value exist in the original? Because not all of your numbers will satisfy it. Okay, so we're just going to try a couple examples together in class. So our original function is 2x plus 5. So step 1, get the first derivative. The first derivative is 2. Then the next step, we said we would factor or simplify, but we can't. That's as low as you can go. What value of x would make that 0? Well, there is no x value, so it'll never be equal to 0. So this is an example where there's no critical numbers, no critical values. Because it's always going to be 2, you'll never be able to get it equal to 0. Okay, so our next example, our starting function is 4x cubed plus 5x squared minus 42x plus 7. Step 1, get the first derivative. Again, this is really easy. We still did derivatives like this back when we were still together in class way back when. So that gives us 12x squared plus 10x minus 42 plus 0, or we can stop it there. Okay, the next step, let's simplify it. We can simplify it. We can simplify, divide everything by 1. You don't have to, but it makes it a little bit easier to factor. Factoring where a is not equal to 1. You guys are experts at this. You've been doing this for, 3 years of your life. So that gives us 3x plus 7 times 2x minus 3. And I set it equal to 0. I did a couple steps there at once. So now looking at it, what values of x make it equal to 0? Well, now this is back to grade 11 pre-cal, right? So there's nothing new. This is our grade 11 pre-cal quadratic equations unit. You set it to equal 0, factor, and then those are our critical numbers. So the critical numbers we would say are minus 7 over 3 and 3 over 2. Do they satisfy the original equation? Yeah, or they sure do. The expression, both of those numbers are fine in there. Okay, and then the third and final example, our original function is x squared over 5x plus 4. This is not grade 11 pre-cal, this is grade 12, or this is calculus. We have to apply the quotient rule to get the derivative of that. So gf prime minus fg prime all over g squared. So we take our g function times the derivative of the f. From that you minus the f function times the derivative of the g, and then the g function is squared. And then you're going to multiply things through. I'm going to skip a few steps just to save some time. So that should give us 10x squared plus 8x minus 5x squared. I'm not going to actually multiply out the denominator. It's okay if I leave it like that. I can simplify a little bit further. This should give me 5x squared plus 8x. Again, it's okay to leave the denominator as it is. And I have a common factor. I'll factor out the x, and that should be as low as I can go. Okay, so that was step one. We had the first derivative. Yeah, that's the first derivative, and then we factored it and simplified as much as we could. Okay, now if we set the numerator and denominator to 0, what value of x would give us a numerator of 0 or a denominator of 0? I don't have to actually set it equal to 0. I can probably tell by looking at it. So before I go to the next screen, I'm running out of room. We have two options. If x was 0, that would make the whole numerator 0. Or if we made x minus 8 over 5, that would give us a numerator of 0. What value of x gives us a denominator of 0? That would give us minus 4 over 5. So it looks like we're going to have three critical numbers here. 0, minus 8 over 5, and minus 4 over 5. But if you look, which one of these does not work? Correct, that one. You cannot divide by 0, so that is not defined. So even though you get three values, you technically only have two critical numbers. So I'll just go to the next screen. I ran out of room. The critical numbers, there's only two of them. The critical numbers are minus 8 over 5 and 0. Okay, so that's part one of this lesson. Nothing too new really, so if you just practice critical numbers, and then part two of this lesson will be a little bit of an extension. And like I said, we're going piece by piece today and next week. So the week after that, we'll put it all together in one question. And the curve sketching, we'll basically review everything we've done up until this point, which is excellent to see if you've been following well with this course. So like I said, we're just practicing, reusing everything we had. So curve sketching shouldn't be that bad. Okay, good luck with the critical numbers.